Hi everybody, I have had a request to explain one of the assignment questions, and this is your modern physics and it's question 2 on photoelectric effect. So I thought I'll just make a video so you can watch it anytime or you can watch it again if you think that might help. So I'll just read the question. So we're looking at question 2 on photoelectric effect, and it's this one. So I'll go through the whole question. So in 1915, a scientist, Robert Millikan. Now Robert Millikan is the one who did an experiment to find out the charge on the electron. So it's quite a famous person. So he was shining light of different frequencies onto sodium metal in a photocell as shown by the diagram. So I will read it like this so you can see what I'm reading. So that's your photocell. He noticed that a current flowed in the circuit when the light was on. That means when the light was shining. By varying the voltage across the photocell, so there's your variable voltage, he found that he could reduce the current to 0, and he called this voltage the stopping voltage. And he had his results, which I have put on the whiteboard. Now, I'll talk you through the answers. A, explain why current flows when the light is on. So the light is shining on the emitter plate, and so the emitter plate gives out electrons, and these electrons are attracted to the collector plate, which is at a positive potential. And since the circuit is complete, so this is a complete circuit, a current flows. Okay, the next one, B, if the frequency of light is 5.50 times 10 to the power of 14 hertz, calculate the wavelength. So let's see. So this is B. So frequency is 5.50 times 10 to the power of 14 hertz. We've got to find wavelength. So the equation that connects frequency, speed, and wavelength is C equals F lambda, where C is the speed of light. So wavelength is speed of light, C, which is 3 times 10 to the power of 8 divided by the given frequency. And you do that and you can get the answer to wavelength. And this particular case, if you want me to solve that, so I just go 3 exponent 8 divided by 5.50 exponent 14, and I get 5.45 times 10 to the power of negative 7. So that's my wavelength. And its wavelength, so it has to be in meters. So that is the answer to question B. Now turning to the other side, assume your real question may have been the one later on, but I'll just go through the whole thing. Now the photoelectric equation is E equals HF, which is equal to EK plus the work function. So what do we have to do? So the photoelectric equation is HF is equal to EK. Okay, and the question is, explain the significance of the term HF. So what is this HF? HF is the energy of the incident photon, where F stands for the frequency of the photon and H is Planck's constant. Okay. Then draw a graph of voltage against frequency given that E is equal to capital E is equal to lowercase e times v, and use the graph to find Planck's constant. So you've got a grid over there. So what you need to do is draw a graph of voltage against frequency, which is in hertz, and remember this is times 10 to the power of 14. And you go 0, and you go 1, 2, and then you go -1, -2, and maybe you could get -3. And then over here, the frequency value. So you're using these values to plot your graph. So these values are on the previous page over here at the beginning of the question. So you've got to use that table to plot the graph here, and you actually end up with a graph something like this. I've drawn it on white paper because on orange it may not show. So your graph looks something like this. Okay, so and then you just go, you need all the way to 10, so you just go 2, 4, 6, 8, and 10. You get 10s like right at the edge. And then what you need to do is, using these values, you kind of plot your points, and you probably end up with something like this. You take a ruler. Do I have a ruler? Yes. And then what you do is, in order to find Planck's constant, you know that when this axis is kinetic energy and that is frequency, the gradient of this line is Planck's constant. And I'll tell you what we need to do here. So mine's not an accurate graph, but it's something like that, whatever that is. Okay, and then you extend the graph to cut both the frequency axis as well as the voltage axis. Now we have to, in order to get Planck's constant, it's a gradient. So what I'll probably do is just look for a line. And there's my gradient triangle. So you find, you get rise over run. But let's say in my particular case, the gradient triangle, my rise was 1.85. It's not accurate. So H is equal to the gradient times, now this EK is E times V, where E is the charge on an electron. So whatever you get on the voltage axis, you've got to multiply by 1.6 times 10 to the power of negative 19, which is the charge on the electron. So in this case, what did I say I got? I got 1.85. And then you divide it by the run, and in my case I got 4.6. So one thing to be careful, this is times 10 to the power of 14, so don't forget that. And then that will give you Planck's constant. It won't be exactly 6.66 times 10 to the power of negative 34, but it will be close. Okay, so that's how you do. Then subdivision 3 is, what is the frequency when the energy is 0? Use your graph to find this value. All that you have to do is look at this intercept. Okay, and whatever answer you get is the frequency when the energy is 0. So that's your voltage axis. 0 voltage means 0 energy. Explain the significance of the frequency value when the energy is 0. This means that this is called the threshold frequency, and below this frequency no electrons are emitted. Okay, and because they don't have, the photons don't have enough energy to release the electron, so the energy of the incident photon is not high enough because it's related to its frequency. And then find the minimum amount of energy required for a photon to escape the surface of the sodium metal, and that is actually the intercept on your y-axis. So it's your voltage axis. So you read off from here, and then you've got to remember, multiply it by the value of the charge on the electron, because you're reading the energy. This is a voltage axis. So you go, whatever answer you get, times 1.6 times 10 to the power of negative 19. So that was question 2, and I hope that was useful. Bye for now.